Hi everyone, I'm Rushab, Solutions Engineer for Data Clean Rooms. If you're using Snowflake Data Clean Rooms, you already appreciate the power of secure governed collaboration. Collaboration is dynamic. New data sets are requested, analytics evolve, and policy need refinement. And this is true across providers and consumers. A potential point of friction we see with technical teams is the fear of making a change that inadvertently breaks the entire clean room for their partners. How do you evolve your clean room without disrupting live operations? It's a valid question, and in the next few minutes, we're going to demystify this process. I'll give you a clear playbook for editing a live Snowflake data clean room, focusing on the safe, permissible do's and the critical don'ts that can lead to a potential fatal state. Our goal is to empower you to maintain and enhance your clean rooms with confidence. So let's get started. Let's start at a high level. The data clean room is ultimately created as a native app package, which integrates the custom logic, security, privacy controls, and links to your underlying data for providers and consumers alike. This includes different objects such as Samuha by Snowflake, the local DB, and the cleanroom specific UUID. Samuha by Snowflake is the primary database that contains all of your core functionality. The local DB contains API procedures that include the provider and consumer schemas. And each cleanroom created under the native app is created with an ID. This includes details around data sets that are linked to the cleanroom created, the policies applied on top of the data, and any templates that are linked into the cleanroom. Before we delve deeper into the joint analytics that can be run inside of the cleanroom, one of the most critical steps is understanding data registration. Snowflake Data Clean Rooms allows linking a large variety of objects into Cleanroom for analytics, from tables to external tables or iceberg tables or views. Having covered registration, it is important to note that once a table is linked, that link is durable and can't be detached from the Cleanroom object by deleting the underlying table. So if there's a need to revoke access, you must unregister the object from the source account by using the appropriate API calls or via the UI. Finally, for your most sensitive data, you may be using Snowflake policies such as row access policies. These policies may be housed in a separate database than your source data. For this use case, we've designed a simple solution with reference usage grants that carries forward the reference usage required to the Samoha app role so the cleanroom can continue to access the underlying data and its policy and maintaining the privacy of the data when running analytics. Here we are in Snowside, and we're going to start with a common scenario. I'm a data provider, and my consumer needs access to a net new data set, and maybe a new way of analyzing it. The way to do that would be registering any new databases and linking new data sets into your Cleanroom app package. Now, currently, the Cleanroom here is only linked to one table, and I'm going to go ahead and execute a command to link a net new data set. Once complete, I am able to confirm the addition of the new dataset into my cleanroom app package. This is one of the most common and safest edits. Instead of granting permissions manually, we use the cleanroom's built-in logic to register and link new datasets. Note that by running this, the cleanroom has automatically created a secure view and applied governance into accessing the new table, but we haven't copied the data over, right? So we have created a secure link to it. And this is a non-breaking change. And now that a new data set has been linked, we could update a policy and create a new join policy, update an aggregation threshold, and all of these are safe, permissible edits. Now let's flip over to the Data Clean Rooms UI, which is another preferred mechanism for providers and consumers alike to come in and make changes to the Data Clean Rooms native app package. Like I covered in the previous section, you are able to add new tables or new data sets into your Cleanroom app package by simply selecting the drop-down in the UI and hitting next. Consequently, having selected new data sets, you are able to select appropriate join policies to be configured on your data set, and specifically any details for templates such as reach and frequency or overlap analysis. Now let's discuss some of the don'ts around how to avoid a failed state. Let's say a data engineer wants to optimize one of the existing tables that are linked to a clean room, and the schema for which is visible here. For example, they may want to change a certain data column or schema changes, or create a net new table entirely with the same name. This may seem harmless, but it's one of the main causes of a broken clean room. When running a create or replace statement, it drops the original table and creates a brand new one. Now the cleanroom app package was linked to the internal object ID of the original table. Since that ID is now gone, the link is severed and the cleanroom could enter a failed state. This change, if made by a provider or consumer, could affect the ability to run queries inside of the cleanroom. Similarly, let's say you decide to rename a column for clarity. In an object already linked into the cleanroom, I decide to edit an existing column, hashed phone, with a different name, or think about adding a new column entirely. Similar to the previous scenario, this affects the existing linkage of the secure view with the clean room. Therefore, this is a breaking change. Finally, the Cleanroom native app operates on a specific set of privileges. If an administrator revokes a select privilege on a shared table, or if you're sharing data across databases and forget to grant a reference usage on the source database, the native app can no longer access the data. And therefore, you would see a similar failed state error with your clean room. Now let's test out a situation where we are making changes in Snowsite as the provider, and we're going to look at downstream ramifications in the UI. So I'm going to go ahead and make changes and a create or replace command, which should be a breaking change into the data clean rooms. Let's have a look on the UI. On the UI, we would expect being unable to run analysis given there have been changes to the original dataset. Once we re-edit the clean room and make the tables available again, that's when we can successfully run analysis in the clean room. To wrap it up with a decision matrix, we would suggest if there are any potential scenarios where there may be role permissioning issues, interrupted installation of the clean room by the consumer, any service user issues or problems, or a cross-cloud or region failure. We'd recommend consumers to leave and rejoin the clean room and help levels set. In situations where there may be role delegation errors, fundamental design changes, or a complete account cleanup, we might even recommend recreating a clean room by the provider to your consumer. The rationale behind leaving and rejoining the clean room is to either preserve the existing configuration and data, or there may just be minor user level issues that don't necessarily involve the recreation of a clean room. However, in case of system-wide permissioning issues, or there are structural modifications required, starting fresh may be preferred. Thank you for watching, and we'll see you in the next video.